Today we're going to be talking about the history of 3D printing, and it goes back quite a bit further than you might think. I'm often referred to as the definitive source for 3D printing news, but today I'm going to be the definitive source for 3D printing history. This episode of 3D printing history is brought to you by Squarespace. Now this first episode is going to be more of a preamble, kind of all of the technologies leading up to the development of 3D printing. I put together this slideshow, which I'll be sharing on my Patreon, but it kind of summarizes where we're at in the current state of 3D printing history. You can see in this picture I'm surrounded by a bunch of my hobby-grade 3D printers that I have at my office. For a lot of industries, metal printing is the holy grail because it allows you to get excellent properties and complex shapes. And I've also included pictures of a couple of patents that were filed in the 80s and 90s that were kind of the first documentations in the patent system about the 3D printing process, and it was on these patents that some of the largest companies in 3D printing were built. But before we get into the modern day applications of 3D printing and the technological boom that occurred in the 80s, 90s, and 2000s, I'm going to tell you about the long history of all the processes, materials, and machines that were required to get us to where we're at today. So to effectively explain this timeline, I've constructed a tech tree of 3D printing technology. Now a tech tree, if you're not familiar, is a kind of a visualization that's commonly used in video games. And to unlock the technologies towards the right-hand side of the tech tree, we're going to have to unlock all of these core technologies over on the left side. 3D printing isn't something that just got invented out of nowhere. We had to come up with a lot of stuff to unlock the ability to even conceptualize 3D printing. So the first things on our list of 3D printing technology are basically all the things that happened before the 18th century. So I'm going to start this story off 40,000 years ago. A long time ago, way back in the early days of man, we had to figure out how to use tools to cut things and smash things. And one of the best ways to do this was with stone or bone tools. Stone tools, once they're sharpened to a fine point, can be used to cut animal hide, cut plant material, and craft all sorts of things. But one of the issues that you have is they tend to be hard and sharp materials that aren't very comfortable to hold. So this leads us to one of the first relevant innovations to 3D printing technology, and that's crafting with thermoplastics. Thermoplastics are the type of material that is used in a lot of printing processes, and they're basically polymers that can be melted or liquefied and shaped into a desirable object. Caveman or primitive man was using bitumen, tar, or pitch, just really thick, viscous materials that you find in nature to shape around these tools, and these materials could be heated up to soften them. Then they could add sand or other additives to it and shape it around a sharp tool to give you a nice ergonomic grip. These naturally found thermoplastic adhesives were also used to bind together clothing, other types of tools. They could be used to fasten spearheads to a stick or to create arrows. So it was a very useful material, and it was one of the first innovations that we had to discover to start us down this path towards 3D printing. If you took a pile of mud and you shaped it into a useful object and let it dry, that would be great. You'd have a useful container, or you could build a structure out of it. But eventually, if the rain comes around and gets it wet again, it'll all melt and fall apart. The process of sintering or vitrifying ceramic materials was discovered way early on in human history, some 10,000 years ago. It's a cornerstone of ceramic technology. And basically, you shape something into a useful object, and then heating them up, you're actually going to melt the individual particles of the clay, and they'll form together into a solid mass that can't be rehydrated. A lot of pottery is made on a potter's wheel, so you basically put a slab of clay onto a spinning table, and then you slowly form that up into the shape that you want. And I consider this to be the original form of additive manufacturing. You're literally starting with nothing, and then you're taking some material and you're building up a useful shape. Another process is the coil pot process. So you can see a picture of it here. Basically, you roll out long strands of clay, and then you start wrapping it around up into the shape that you want. You can actually see the layer lines here. This looks very similar to something that would be 3D printed in vase mode. And I like to think that this is the original inspiration for the idea of vase mode 3D printing. I mean, why else would you call it vase mode if you weren't inspired by the way that vases were created in the early days of pottery and ceramics? Not only does this process tie into the way that we 3D print things, but also the material science behind it. The way that you're actually solidifying small particles by heating them, this process of sintering. I just think it's kind of interesting that the most advanced applications of 3D printing technology used in robots, airplanes, and satellites relies on the sintering process that was invented tens of thousands of years ago. So now that we've unlocked kind of the baseline technologies that we need to progress further along this tech tree, I'm going to tell you about today's sponsor, Squarespace. I've been using Squarespace to design and host my own website for over 2 years now. I use it to post things like tutorials, test data, news articles, and other useful information that wouldn't otherwise fit into a social media post. I'll actually be creating a companion article to this presentation on the history of 3D printing, which I'll link to down below. Before starting my website with Squarespace, I didn't really have any web design experience, but their user interface called Fluid Engine makes it really easy to build web pages from the ground up. So you can use your phone or computer to drag and drop pictures, links, buttons, and all sorts of stuff, and it makes it really easy to bring your creative visions to life. But after getting started with a free trial and just drag and dropping things onto a page and coming up with something that I was really excited about launching, I was like, you know what? I think I should just go with Squarespace. And Squarespace is a great way to establish a professional web presence. And with Squarespace domains, you can even pick your own domain name. So when you go to nathanbuildsrobots.com, you can see that's me. But it's nice to know that with Squarespace, they're constantly adding new stuff and developing new features to help you get the most out of your website. So check out squarespace.com for a free trial. The best part is you don't have to pay anything until you're ready to publish your website. Once you're ready to launch your website, go to squarespace.com/nathanbuildsrobots to claim a 10% coupon off your first purchase of a website or domain. Now let's get back to our presentation on 3D printing history. So where were we? Alright. So if you look at the pyramids, this really introduces us into the idea of building things up layer by layer. You can even see the layer lines here. Aliens 3D printed these. A lot of the core innovations that were required to do 3D printing planning or slicing were invented by masons. Let's say you wanted to build a large tall object. Well, you've got to start from the bottom and build it up layer by layer, making sure that the lower layers can support the higher layers. And these are all kind of the things that we have to worry about in modern 3D printing processes. Things like overhang angles. You can't stack the bricks over too steep of an overhang. You had to do bridging, so usually when you build a structure and you want to have a window, they'll build up to a certain point, they'll get to the top of the window and then lay a large beam across the top. So, that's the first instance of bridging as you're building something up layer by layer. If you look at a lot of ancient walls, they had their own version of infill material. So you'd build up both sides of the wall using bricks and then just dump earth into the middle. So just soil or whatever type of gravel that you'd want to throw in there and compact it. So you have nicely formed walls on the outside and then cheaper infill material on the inside. And they even had their own version of support material. You might see a large arched structure like an aqueduct or some feat of medieval architecture and wonder, how are they able to build all of those blocks up into the top where they finally set the keystone in so that you have a self-supporting arch? I mean, without that top block, the rest of it's just going to cave in. So you had to fill that up with a support material. You could stack bricks up in the middle and then remove them after you've finished the structure. But they took it even one step further and even had their own version of soluble support material. That was in the form of bundles of wood or scaffolding that you built up. And then once you've completed your structure, you just strike a match, or I don't know, they probably didn't have matches back then. But you set it on fire, and then all of that material just burns out and you're left with your stone structure left behind. So in a way, this idea of building things up layer by layer, overhangs, bridges, support material, soluble support material, even infill, was kind of invented and pioneered by the Masons. I would say modern day slicers are using processes that were mastered by ancient architects. So again, it's interesting to see this modern day parallels to ancient processes and how that's all tied together. Then at some point in human history, we figured out how to take metal ores and refine them and craft them into solid metal objects. I put blacksmithing here as one example. Really, it's an overarching theme of metalwork. So the ability to create and form metals, whether that's with blacksmithing, casting, or any of the other forms of shaping metal, these were all things that we had to innovate and come up with before we could create our metal 3D printing processes. Eventually, the Industrial Revolution came around and we started inventing all sorts of machines to be able to do the work that we used to do by hand using a machine. I mean, when you think about 3D printers, really that's a machine that does a job that you would normally have to do by hand. So this idea of offloading handwork into a machine stretches deep back into human history. We started making machines, and eventually, through this long line of machine making, we created the 3D printer machines. Another core discovery was electricity. Without electricity, you can't have motors, you can't have electric heaters, you can't have computers, and all the sort of stuff that we need that 3D printers are highly reliant on. The earliest experiments with electricity date back a long time ago. People were playing with electric eels and thinking they could use them to cure stuff. It's just in the last couple of centuries that we've really started to harness the power of electricity using radios, light bulbs, and all sorts of stuff. But most relevant to the world of 3D printing, I guess we need motors, motor controllers, electric heaters, and computers. That's how that all ties together.